Hello. I wish I had a smokier voice. The oddball transformer that I have in my Jet City head awards me some opportunities. Today, we have a Soviet GU-29. I'm gonna try to proof of concept to see if I can get it operating, and then I'm gonna decide if I'm gonna move further. So I have no idea if this thing will actually sound good in a guitar amp application. So I don't know how much money and time I want to invest into this, but at least we can see if we can try. Now, if you've been following the comedy, you know that I purchased a broken Jet City amplifier. It needed a power transformer. To solve this problem, I replaced it with this NOS unit I found on the Bay of Ease. And to get it going, you needed a voltage doubler. It only has a 170 volt secondary, so we had to double that voltage up to get it into the range that we needed for this amp to operate properly. That means I can use it as a proof of concept for a tube that doesn't run at a standard voltage. Like this guy. The GU-29 runs at a heater voltage of 12 volts. That's one of our first problems. However, it does have two series heaters, much like a 12AX7, so we can run it at 6 volts if we have to. Now, with what I have prepared, that's not a problem. I can adapt that. Looking down the line, we have an anode voltage of 750 volts, so it's gonna have no problem operating at guitar amp voltages. However, our grid 2, our screen grid, only 225 volts. That's our problem. Most guitar amps don't have separate screen grid power supplies. You know, some of the bigger bass amps do, because when you're pushing 50 watts out of a 35 watt tube, you need to keep that screen grid under control. Ampeg, some Trace Elliott, stuff like that. They have separate power supplies, but most guitar amps don't. Now, one of these tubes is rated for a theoretical 40 watts. And, well, there's no straight answer on how we get 40 watts out of this tube. If it's from the two sections together, and these sections are 20 watts each, or if these sections are 40 watts each. I'm inclined to think the earlier because these do not look big enough. Let us compare it against a whatever 6L6. That's a 30 watt assembly there. And then look at these guys. Yeah, I think that's 20 watts a side. Now, if you don't know the GU-29, it is actually two tubes in one. We have two independent tetrode, beam power tetrode sections. I believe they're beam power tetrodes and not pentodes. And you got two anodes at the top. This thing looks like it's from outer space, and that's why I found it so fascinating. Sure enough, a little bit of the gargling online, I found that indeed people have used them as power tubes in audio amplifiers, even though I think they're supposed to be like an RF broadcast tubes. A lot of these wicked power tubes you find, they're designed to broadcast radio waves out antennas, not sound out of amplifiers. Now, I ordered two of these tubes, but the seller forgot to ship the second one. Even though I only have one of these, I should be able to get it working in a push-pull amplifier by using these two sections push-pull from each other. So the reason why I brought up the Jet City transformer is because the voltage doubler circuit awards us an opportunity where we could theoretically tap power off the center right here of the voltage doubler and get half the voltage, the correct voltage, roughly, that we will need to run the screen grid. Now, what often happens in tube power supplies is we got our plus in from the rectifier, and then we have, you know, one capacitor, and then that couples up to another capacitor, and then, you know, that's our basic ground, or our circuit negative. They will often have between the two some balancing resistors. It is harder to draw on paint than I expected. That looks, wow. I could sell that for $1 million in a gallery. That's such abstract art. Normally, you can't center tap off here. Because what happens is we got these two capacitors. They're often like 200 UF and rated for something like 300 volts. And then once you couple them together, you get a capacity of 100 UF by 600 volts. Wow, I should really quit while I'm ahead with this drawing. Now, these little resistors, they're probably something like 220K. Is that actually a 2? They're the balancing resistors, just to make sure the voltage is correct between these two capacitors. You can't draw any actual current off the center because there's no current potential. Any current that's going through here is being used to feed the actual circuit. Also, you can't pass actual current through capacitors. So none of the current that's at the top or the bottom is getting to the center. And these 200K resistors are too small to pass actual load current. They would incur way way too much of a voltage drop or a current drop in this capacity because their voltage is forced based on their split. However, on the voltage doubler circuit, we have an actual side of the transformer connected to the middle here. So there is actual current capacity there. In theory, I should be able to tap the screen gear off the center. So that's what I'm going to be trying here today. I gotta kind of rig this guy up to get that done. How am I going to connect it though? I think to kick this off, I'm going to need some wire and some tube bases. Let's start by scrapping wire off this old power supply. Not necessarily voltage rated, but it's roughly the right size. Oh, look, we got a nice purple wire. We'll grab a couple red wires, a couple orange wires. I'm also going to need a couple black wires. Hey, we got green and blue wires. We can use that to pass signal. Yes! That'll do. All right. Scrap wire, couple bases, couple 1 ohm resistors for reasons. The anodes, we're going to connect to these 1 ohm resistors because this tube shares a common cathode. If you observe the pinout diagram, 4 is both cathodes at the same time and also both beams. We also have a shared screen grid. The only thing that's separate on this tube is the anodes and the control grids. Now, if I recall correctly from my high school math class, pin 3 is our anode. One of these bases is labeled and the other isn't. That's fun. All right, so I've rigged up these tube sockets here. One is the master tube socket. We got purple is going to be our main ground to go to the common cathodes. The two blacks are going to be our heater circuit. Orange is going to be our anode. Blue is going to be our control. And then on the second socket, we just have anode and control. That's all we need. So now we have to get these connected to the receiving tube socket. Receiving tube. Yes, I'm sure. This is not a receiving tube. It's a transmitting tube, isn't it? Isn't it? All right, so according to the pinout, this big beast right here, number 4, is our main ground. That is a big ground prong. 2 is a control grid. Make that our primary control grid. We don't want to solder these on so nice that's going to be hard to unsolder because we got to reuse this socket after, once we officiate this mod. Well, this old Russian steel is oxidized. It's not taking solder that well. Number 3 is our screen grid, which is being done differently. Our anode is actually on the top of the tube. It doesn't go to the socket. Let's get our heaters hooked up then. That socket shows 5 connected to ground. We can't have that. That's not going to work. No, 5's not connected to ground. So if I'm reading the data sheet correctly, 5 is going to be the center point of the 6-volt heaters if we want to wire it 6-volt heater. And then 1 and 7 over here, that's going to be our 2 heaters we joined together also for 6-volt functionality. Otherwise, 12 volts would just hook to 1 and 7. So we're just going to kind of jumper that over like this. Now let's get our secondary hooked up. Pretty much here, we just get a control grid signal to pin 6. So for the anodes, we got those little pokey bits sticking out the top, right? For that, we use a component called an anode cap. I didn't want to solder to these things yet, but we might as well. All right, check these out. This piece of the center kind of screws out. And we just have a tiny little solder lug in here. That's got to be tricky to solder to. Going to need to bring in the clapped out helping hands. Just for fun, we'll stick it in the vise. Oh, just like that. Got a splash of solder to prime it up. Get this wire nice and wet. And just stick that in there. All right. We're going to have something resembling an anode connection now. So that guy just slips in there. And then we screw the little holder into place, which is annoying. Toothpick ought to do. There we go. Spun up there. I just go do that same thing to the other. Okay, so we're mostly connected. Mostly almost ready to get this thing running. I guess we'll vise this up here to hold it nice. Use a vise to hold it nice. And then to feed our screen grid, I'm going to use an alligator clip lead. And that again is pin 3. All right, let's see if we can't just YOLO bomb these 2 things together and make this work. So the tube itself, we socket it here. We have to determine which anodes match which side. Oh, we got a little bit of quantum entanglement going on here now. Come on now. Okay, we'll pop this this side. So we will get this plugged into this side, same perspective as the tube. And this guy will go to the other side. And prospectively, this anode on this side, this anode on this side. And then we need to tap screen grid off the center point here, which is actually like only establishable via this brown wire with nothing to connect to. I'm gonna have to solder something onto there to grapple. Like there's 2 holes there because of the components that I removed to make this happen. So somewhere I have little bits of wire. Even better, I'm gonna jam a 1 ohm resistor in there so I can track screen grid dissipation. That's a win-win. All right, so we clip this onto there like that. Now I've measured the voltage off that center point. It's more like 240 some volts. Yeah, so it's a little bit over, but I think it's close enough. Oh geez, this popped off. I think it's close enough that, you know, it's not gonna be instantly destroyed, this tube. We're gonna get our bias meter established. I'm not exactly sure. Blue wire is sleeve. Which side's sleeve though? I think this one. Now we calibrating this. What do we want? Based on 220 watt tubes. Now it's a common cathode, so our bias is just gonna reflect as one value. Our max bias is gonna be 58. I might shoot to 45 anyway. All right, so are you ready for this? Are we about to blow up this tube? Or are we about to establish sonic domination? Standby off first, and we will see if the heaters go. Yes, I am seeing heat action on both sides of the tube. All right, time for some B+. 2 milliamps, dissipation. All right, let's tweak on our bias. Whoa, I'm out of bias range. The bias knob is all the way up and I only have 10 milliamps. Okay. Now, mind you, with that much lower of a screen grid voltage, yeah, it's probably not going to bias the same. Well, that's tricky. All right, let's probe some voltages here, bud. So our screen grid voltage is 239. So that's pretty close. Can we get an anode voltage here? 478. Can we get a negative voltage? 33. So I need less negative voltage. And the only thing I can think to do is we have... There's a resistor on the board here that shunts the bias circuit to ground. I'm not going to rearrange the camera. It's R18. If we jumper that, we should be able to bleed off more bias voltage and hit target. So let's just clip there and clip there. Now let's adjust on our pot. Okay, there we go. There we go. 44 total. So now the question is, what voltage drop do we have across those anodes? How balanced is this tube? Okay, so in order to test on the anodes, we need to find 1, 2, 3. I need to clip onto pin 3 if our alligator clip will let us. Piece of crud. And that should be the red anode. So what voltage drop are we seeing here? 18 milliamps on one side, 25 milliamps on the other side. So these are grossly out of balance, which is something that my research did show. That these tubes, they need individual bias circuits. You need 2 individual bias circuits just for one tube. Setting these things up to work on an amp is going to be complicated in that respect. But it's gonna work now. We might want to tame the bias down a bit since it's so out of balance. Well, let's hear how it sounds. Let's check to make sure there's nothing. There's sound. I hear a little bit of out of balance hum. And one caveat is I don't have a microphone set up, so you're not gonna hear frontline assembly here. Let me check my EQ settings. Yeah, that's fine. Turn treble down a bit. Presence is already down. We might want a bit more depth. Some bass. Yeah, okay. So far, it seems like we're going to Crunch Town. Oh, she's struggling, but I saw some huge fluctuations in current draw. Now, mind you, this setup here is kind of overpowered. It's just going to keep sucking back current. I think we need to bring the bias down. But so far, how do I describe the sound of it? There's a lot of high end. Like we're hanging out in Crunchtown, bud. There's low end. There's quite a bit. Unnaturally so. I can see how this might qualify to be an audiophile tube. The mids sound very scooped though. There's not a lot of, you know, this might sound good in a dark amp like the Jubilee. Maybe I should try it with that, except we have to find a way to get the screen grid voltage where we need it to be. Whoa. She's down to 7 milliamps because I dialed in a bunch of negative voltage to try to keep it tame at the higher volumes. How successful was that? I don't know, because it was jumping well into the hundreds of milliamps. So we need more than just one of these tubes. And the sound of it was just, I don't know if it sounded good. It's very bright, very harsh. But then the two sections are so out of balance. Like, oh, we would need to get the independent bias circuit going. It works though. I am playing guitar through a Soviet military surplus GU-29 tube. This thing, it came from outer space. But it definitely, it works. It works. So seeing here, I've rather obnoxiously hacked in something resembling a bias balance mod. The hope is I'm going to be able to swing the bias to and fro to the tubes that I need. Pretty much just taken right off the Rob and Robinette website. So, let's see if I can't get this dialed in now. It's just a pain because we have to keep moving the meter connection here. So let's try clipping on to this anode. And let's try metering this guy here. Okay, we're seeing a voltage drop of 8.6 of 20 milliamps. Let's see if we can get that to 10. That's 10. 10 of 20. Let's check the other one. Oh, 10 of 20. Okay, we've got balance now. Let's bring our idle voltage up. Trying to situate it about 42. In which case we're getting 18 on one side, 22 on the other. Let's adjust that. 21, 20 on one side, 19 on the other side. So this is working better. This is working better now. Let's bring her up to 45 milliamps. Or no, we'll stick it at around 40. Come on now, bud. 20 on that side, 19 on that side. Okay, we got slight deviations then. 19.9, 19.6. I don't think it's getting much better than that. So now that this guy, we believe, is balanced, is it gonna sound any better? Check our wattages are good, bud. So 460 by 40, 470 by 40, 18 watts. $465 by 70, 32 watts total. That's nearing max volume. Why is it making so much noise? that thing sounds awfully funky. We were hitting almost 40 watts of dissipation on this guy, but there's a lot of strange noises. Now, the only reason why I think that we'd have these strange noises, other than the fact that maybe there's something about what I'm doing here that the tube really doesn't like, is, you know, the fact that we have all these guts hanging out here. You know, we have the signal wires, the control grid signal wires, and they're just kind of commingling here. Maybe, just maybe, they're picking up interference, and we need this socket chassis mounted in such a way that's not going to happen. So this project moving forward, Well, I'm going to move on to the next experiment, and that is if I can regulate the screen grid without using this trickery. That's our next determination. Now, once upon a time, the way I accomplished this task in the past was by using a vacuum tube voltage regulator. Basically, just using a spare power tube and hooking it up into a voltage regulator kind of configuration. And it worked. It worked, but, you know, quite silly. So, screen grid. On the other side of one of these 1Ks here will give us full voltage screen grid. So, I devised this contraption here, and it is based on a schematic that I found on the line. I guess I would have to credit a guy named Doug D. Young for this. It was some sort of power supply for some audiophile tube amp, and it used these MOSFETs for the purpose of regulation. Somewhere I had a circuit board. Oh yeah, it was this guy I got those capacitors off of. It's got quite a few of these MOSFETs on it that actually turned out to be high voltage. And right here mounted, I have a 500 volt rated MOSFET and a circuit basically rigged up based on that in a way that allows me to use it as a voltage regulator. So the basic fundamentals drawing across here is we have voltage input on the drain, voltage output from the source. Basically these are NPN spec and you're kind of wiring them backwards, but that's fine. Now, I don't know what the Zener's for, but this 1K connects to the grid, and then you see we have a 200K here and a 4.8 meg there. Basically creating a kind of voltage divider, which is going to set reference voltage. That's going to tell the MOSFET what's to do. I've simulated that experience on this board here. So voltage comes in here on the breadboard, it goes through to the drain, and then the source is the other side here. It's connected off, and we got a buffer capacitor here, you know, because we need capacitors all over the place. And on the gate, there's the 1K as reflected in the photo. Here is a buffer capacitor to kind of make sure that the voltage is stabilized here. And then to the input are two 220K resistors to try to make a voltage divider to set our voltage. And then I've put this potentiometer in the center here to hopefully fine calibrate it where we need it to be. Now, the only unfortunate thing about a MOSFET, it's going to start sucking back or putting out a lot of heat. Basically, using a MOSFET in this fashion pretty much turns it into a controllable or variable power resistor. So, let's fire this up once again now that the screen grid is connected through this contraption. Assuming, double check. Yeah, it looks like I got everything hooked up the way I feel it should be hooked up. Hopefully we're not up in smoke. Oh, well, the tube's heating up, so something's going right here. All right, well, what's our output voltage? 229. Well, what do you know? That's exactly the effect we were going for. Maybe if we tame our screen grid, we'll get better tone? Well, I'm not holding my breath at this point. I think the only way to get better tone is to actually fix this thing so that it's set up the way it's supposed to be in a chassis. Okay, well, let's see if we can turn this. Okay, yeah. Voltage is changing. We want to bring it down. 225. That's target right there, bud. We'll go down to 220. Sure. This thing's isolated. I shouldn't get electrocuted, but that thing might start putting out heat. Let's see if this thing still sounds... Oh, our bias has gone down. We better bring that back up to spec. We'll bring it up to 40. Now we're going to assume our balance is still balancing the way it should. And we'll double check that these voltages didn't change. No, 212. It's a bit low, but we might have a genuine bona fide screen grid power supply now. Oh, it sounds way darker now. Wait, I had the treble turned down from the last experiment. All right, let's bring her up. I think I know what I'm doing wrong here. Because I'm running two so low output tubes, I need more load, more transformer load, I think. We're plugging an 8 ohm cab into an 8 ohm input. I'd have to plug it into a 4 ohm input, which I don't have. I need a 16 ohm cab. Okay, I'm gonna go swap cabs here. I wanna put more load on this. All right, 16 ohm cab into an 8 ohm tap. It's gonna double our impedance load on the tube itself. There is all sorts of artifacting, if you can hear. I'm hoping it shows up in the audio. It kind of goes like the tube's farting out. It is not liking something that's going on here. What am I gonna do with this thing? I had this plan to build like a chassis and then put a couple tubes on it. Set up a bias supply so I could balance it perfectly, and then you know, have those two bases that I had there and be able to put it into any amp and then get it to plug this into any amp. But it looks like that's not going to be a thing that can happen unless it's just an issue of interference, because you know, my signal cables are just hanging out ass in the breeze here and it's causing signal interference. Maybe if I chassis it up nice, it'll be different. It definitely doesn't sound that good. It sounds like it wants to sound that good. It sounds like if it wasn't an audiophile application with an amplifier that was voiced to use this tube, like it has some tight low end. It has some potential, some tight low end and some very open highs. The mids are just flat like a pancake though. No roar, you know? I don't know that it would make a very good sounding amp tube, even though I'm still tempted to like build an amp just for it and like stick them in there and just see what happens. But as it stands right now, I'm not sure if this is worth pursuing anymore. It was a fun experiment. I'm gonna have to scratch my head here and debate on whether I want to spend resources setting this thing up to work in an actual amp properly. Not if those are the sounds I'm gonna expect. Basically, you're gonna do all this work, it's just gonna like, okay, done. But you know, we quite possibly did solve a problem, sorting out a proper power supply here. Oh, it looks like it's not getting too hot. I guess it doesn't need very much current. That's handy because I kind of need something like this in other applications. So I do believe we're going to be seeing this regulator circuit again. But I think that's enough for today. I'm not sure what else to tell you guys here. Russian tube experiment number 1. What's next? You know what? It just occurred to me. We could have a circumstance where there's interference having a push-pull in a single tube in such close proximity. I bet you that's part of what's going on. And once we split this up into 2 separate tubes, it's going to be a horse of a different color. So yeah, maybe this does warrant further exploration. Either way, stay tuned to find out what I'm going to do next. I guess it's not a good idea to use one of these alone on its own. Single-ended. That might be where the party is. But that is awesome. I figured out a power supply. Yay!